Okay, now I'm going to try to keep this clear and simple because I have to go to the doctor. So you got some things mixed up, but not too bad, not too bad. So you don't always want to use the quadratic unless you have to. So definitely what the quadratic tells you is the exact x values on the x-axis. Keep in mind, some parabolas don't cross the x-axis. Some just cross once at the vertex, and some cross twice. What the discriminant tells you, which was b, I believe it's b squared minus 4ac, minus 4 times a times c. If that's positive or above 0, then it has two spots on the x-axis. If it's equal to 0, the vertex touches. The vertex touches. And if it's below 0, it never touches. However, before you run to the quadratic, you should always see if it's an easy factor or factorable at all. For instance, something like this is easily factorable. And this tells you that minus 1 comma 0 and minus 5 comma 0 are the factors. Now, be aware that if you use the quadratic formula for this, where a is 1, b is 6, and c is 5, the quadratic formula will spit out minus 1 and minus 5. It will spit out the actual x-intercepts, whereas factoring spits out the factors and you have to take the opposite to find the x-intercept. So you should always factor first for break even. So things that hit the x-intercept, here's some of the questions. When does the ball hit the ground? Where's the break even point? What else would be right at the x-axis? Anything that hits 0 or so that's usually the two. When does the ball hit the ground and where's the break even point? Now keep in mind also for some questions, like a ball question where something's thrown from a roof, the ball hits the ground over here, but the ball also hits the ground back in time over here. Usually you can say, we will ignore this answer, but you should find it because it is back in time, and this is the only one that matters. For businesses ones as well, sometimes this occurs. For instance, a profit margin, where the products over here to the left of the y-axis here, over here, those are negative, like making -6 shoes. We can't make -6 shoes. So usually we're only concerned about the break-even point here, and this is the max. So whenever you have a product cost, so profit is equal to revenue minus cost. Be careful about this minus cost. You have to apply this minus 1 to all the terms of cost. For instance, if it's 6x plus 3, this minus 1 makes it minus 6x minus 3. That's the problem with revenue minus cost. And then you have to add up your like terms with your revenue, and you end up with a quadratic. If they want to see max profit, that's completing the square, always, because you have to find the vertex. Another trick, find the b value, or the bx value of the vertex, minus b over 2a. Another trick, partially completing the square and putting the x value into the formula to find the y value. So max profit and highest point of the ball, that's the other one. When does the ball, what is the max height? What max height does the ball reach? Does the whatever object reach? That's also vertex. When the ball hits the ground, or when break even. So why is it called break even? Because here the y value is 0, which means they make no profit. That y over here is profit. So they're saying when it hits the x-axis, that's when they don't make any money. It's called break even. This is their max profit. And they might say, what category is profitable? And you would say from this x value to that x value makes a profit because it's above the x-axis. Okay, so that's when you would use it. So for these specific questions, Describe the function. This is a downward facing parabola. We'd have to factor out the -1. Determine the maximum result possible. So that's a completion of the square. We can, once we factor out -1, we can see that's negative 7.5 because you have to factor out -1 for both these terms. And then when I met negative 15 rather, and then when I half that, it's negative 7.5, which means the value of the x for the vertex is 7.5. And we did this one together. This one you have to factor by grouping. The first two and then the second two in your brackets should match. Then you apply one to the length and the other to the width. This one tells us, oh no, that's this one here. What is the perimeter of the rectangle? So again, factor by grouping, and then you add up those terms. So I can see I can take n squared out of this, I get n minus 6. And I can take -8 out of this, and I get n minus 6 again. And so you're left with n squared minus 8, and n minus 6 is the two factors. And so you would add those up. So it'd be n squared minus 6, let's see. No, minus 8, n squared minus 8, plus, yeah, that's a hard one to do. So we'll do it together. The cost, so this one is, this shows the cost, and this is the revenue. So it's minus 3x squared plus 41x minus 5x minus 27. So minus 41x minus 5x is minus 46x. Then you have to factor out this minus 3 from the first two terms. Then you have to partially complete the square because they ask what's the max profit. So that means a completion of the square. This is a business. They only give you the profit formula already. They want to know how many snowboards must he sell in order to break even. So that is a quadratic. First you factor out -1. And you get 2x squared minus 26 plus 11, and you find what number adds up to 22. Or sorry, it multiplies out to 22 and adds up to minus 26. Well, that's, you're not going to be able to find it, so you have to use the quadratic for that. So you go back to this. A is -2, B is 26, C is -11. The population of the town has grown at a rate of 2.17%. So we'll do that one later. So again, max height of a ball is completing the square, or minus b over 2a to find x, or partially completing the square to find x and plugging in the equation. Break even is factoring, and if you can't factor, the quadratic equation.